Hi everyone, this is Hannah Lee, and today I'm going to review some SAT math, especially some complicated math questions. So let's get started. Question 11, it asks the graph of the equation y equals to mx plus b, where m and b are constant, is shown in the xy plane above. Which of the following is the graph of the equation y equals to 2 mx plus b? So first of all, we have to find out what is m and b, and it's obvious in the graph. So the y-intercept is 0,2 and the slope is 1/2. So m is 1/2 and b is 2, so it will be this formula. Then, since we know m is 1/2 and b is 2, it's easy to find out this formula as well. So it will be 2 1/2x plus 2, so it will be x plus 4, and this will be the graph that has y-intercept as 0,4. So it's not 0,4, it's not 0,4, and this 2 has y-intercept as 0,4, but the slope is 1, which means this slope is 1, but this is 1/2. So the answer would be C. The answer would be C. Then the next question, which is 21, the question is, if k squared plus 6k minus 10 is 0, which of the following is a possible value of k plus 3? Then, okay, let's put this equation in the graphing calculator, and I'm going to put it in the decimals. X squared plus 6x minus 10. Okay, then the solution would be x equal to minus 7.359 and 1.359. Then we have to add 3 for each of the x. So it would be minus 4 point something, and it would be 4.359. And if you put the root 19 into the calculator, it comes out as 4.359, which is equal to this value. So the answer is C. Then let's move on to the next question, which is question 15. It says an integer from 1 to 20 is selected at the random. If the number is a multiple of 3, what is the probability that is also the multiple of 5? Okay, so you can just say, okay, it's the multiple of 3 and it's a multiple of 5. So 15 is the only answer. So it would be 1/20, because 15 is just one number from 1 to 20, right? But this is not the answer. So you have to get through the process of narrowing down the numbers from 20. So it says if the number is multiple of 3. So you have to just think of the number from only from the multiple of 3. So which is 3, 6, 9, 12, 15, 18, then 21, then this is over 20. So then from those 6 numbers, you have to get the probability of getting 15, which is 1 over 6. So 1 over 6 is the answer for it. Next question is number 19. And the question says, a class used the catapults to launch 2 kinds of the gummy candies. The dot plots record the distance the gummy candies travel in inches. Which statement best compares the standard deviations and the means of the distance traveled of the 2 kinds of the candies? Okay, so first we have to find out the standard deviation, and second we have to find out the means. So these are the graph, the recorded dots, and if you roughly see the graph, it looks like this, and this one looks like this. Oh, like this. Okay, so when you say the standard deviation, when there's a mean, if the standard deviation becomes like this, that means the standard deviation is low because it focuses on the mean. And if it looks like this or like this, like it's kind of spacious from the mean, it means the standard deviation is high. So from this graph, we can see that standard deviation is greater in the warm gummy candies. So it says standard deviation, the warm gummy has greater standard deviation. Then number C and D is eliminated. Then let's see the mean. For this graph, I think it's kind of complicated to compare the means just by looking at the graph. So I think you have to use the calculator. So before using the calculator, let's kind of labeling the graph. So this would be 50. So this would be roughly like 46.5 something. Let me just label like 60. This would be 70. This would be 80. This would be 90. This would be 100. So let's find it out. Okay. So 45 plus 46.5, right? So it's 46, 47. I think it would be 47 though. Yeah. Let me go with 47. Then 49, 51 plus 51 plus 57 plus 61 plus 65 plus 65.5 times 2 plus 60, where is it, 69 plus 70, 3 plus 74 times 74 plus 75 plus times where's times 2 plus 81 times 1 2 3 4 5 5 plus 82 times 4 plus 83 times 3 plus 84, 1 of 84, then 2 of 85, then 86 plus 87 times 3 plus 88 times 2 plus 89 plus 97 plus 101 plus 103 times 2, 1 plus 104. Then, wait, how many dots are there? Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. There's 41 dots, right? Okay. Wait. Oh, wait, what happened to my... Okay, what happened to my calculator? Wow. So it's approximately 90, it's approximately 79.9756. Okay, then let's calculate the next one. The reason why I calculate just not roughly looking at the graph is because you can just say, oh, this one has a lot of 80 something, so this would have the greater mean value, but it's kind of not obvious because yes, it is true that it has a lot of 80 something on the graph, but warm gummy candy, this graph also has a lot of value on this size too, like very high values, like 145, like 155, like that. So I think if you want to get the as many as math question you want, I think you have to just calculate it just in a safe way. Okay, the next one. 65. Okay, wait a thing. Okay, 65 plus and these values, it ends up with 105, but this one ends with 155 and start with 65. So even though it seems like this graph has a greater values, but in fact the labeling, when you see the labelings, this one has much more greater values. But let's calculate the mean. So it would be 70 plus 74 plus 75 times 3 plus 80 plus 81 plus 93 plus 94 plus 95 plus 95 plus 100 plus 100, then 3 of 103 plus 107 plus 108 plus 109 plus 120 plus 130 plus 135 and 137, 140, yeah, 140 plus 144 2 times, then 150, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, 26, 27, 28. There's 28 by 28. So the mean value of it is 98.857 something. So the warm gummy candies has a greater mean value, because when you compare 79 to 98, it's much greater. So the answer is the warm gummy has. The answer would be A. The next question is question 21, and this is pretty hard. It says, the nutrition facts on the container of the mini pretzel state that each serving of the mini pretzel contains 310 milligrams of sodium, which is 13% of the recommended daily value for adults. If X servings of the mini pretzels contains P% of an adult's recommended daily value of sodium, which of the following expresses P in the terms of the X? The reason why I say this question is pretty complicated is because mostly when you see the percent in the question, and the question is like, oh, find the expressions of the something like that, and there's a percent and you don't really know what to do, you tend to just choose the answer like 1.13, like this or this or this, that looks like a percent, but okay, yeah. So for this question, since this is pretty sophisticated, I recommend you just think as simple as you can. So like, okay, you have to contain each serving of the mini pretzel contains 310 milligram of sodium, and this is 13% of recommended daily value for adults, right? And if you're serving X servings of the mini pretzel contains P% of the adult's recommended sodium, which of the following expresses P's in terms of the X, right? So those are both saying about mini pretzel, right? It's not like, oh, this one is talking about like pizza or this one is talking about pretzel, not like that. This all talk about mini pretzel, and this all talk about the same recommended value of the sodium. So this is, the 13% is about one serving of the pretzel, right? So when you contain one pretzel, you would get 13%, 2 pretzel, 26%, like that. So by knowing this, you can kind of eliminate the answers. When you put 1, does A become 13? No. Does B becomes 13? No. Does D becomes 13? No. But C, yes, when X is 1, it becomes 13. When X is 2, it becomes 26, like that. So this is pretty hard, but the answer is C. Not something that looks like related to percent. And the reason why it doesn't look like a percent answer, because this is P%, not just P. And this is 13%. So percent it matches. So the answer is the next C. Question and the last question of the lecture is number 22, and it says, in a 2020 survey of 2,000 US adults who were elected at random. The survey participants were asked, do you support ending qualified, what does it say? Immunity for the police? It's immunity. There's I over here. Immunity for the police or those surveyed. 63% responded that they supported ending qualified immunity for the police. Based on the result of the survey, which of the following are reasonable conclusion? Before starting to the options, you have to realize that random values over here, when you say random values, it means the values are very trustful. But of course, there will be some standard deviation because this is not the exact value. And the random value, the why it's trustful is because it means you didn't have a bias when you choose the participant, right? So it's random, so it's very trustful values. So let's go into the options. A, 1, it says if another 2,000 US adults selected at random were surveyed, about 60% of them would respond that they support the ending qualified immunity for the police. About. It's also random, and it didn't say exact 63, it says about. So yeah, this is reasonable. 2, it says if another 2,000 US adults selected at random from a specific US state or survey, about 63% of them would respond that they support the ending qualified immunity for the police. The question said 2,000 US adults, not a certain state US adult. And this is narrowing down to specific US state. So this doesn't make sense. 3 says exactly 63% of the US adults supporting ending qualified immunity for the police. This is not exactly. So the only option that is right is A. So the answer would be B. So today, this is the end of our lecture, and today we learned about some complicated and tricky SAT math questions. Thank you, and this was Hannah Lee. Thank you.